Muted.
So let's continue our collection framework session today. Now, okay. And before that, I'd like to say sorry that I keep on changing the timings. That is because of some ad hoc works that come late in the evening. Okay. Because of that, I kind of like start working and then end up it ends up late in the evening, very late in the evening. That's why. Okay. Yeah. Hope you all understand, and thanks for your patience. Okay. So yesterday we discussed about the collection interfaces, right? So let's see which are all the collection interfaces that we discussed yesterday. So these are the interfaces. At the root we have a collection and list, set, and queue interfaces extends collection, and respective other interfaces, sorted list and the navigable set, and the DQ, which extends queue interface. Okay. And at the bottom we see the implementation of these interfaces. Okay, so let's start with the collection classes today. So as we have the collection interface at the root of your collection hierarchy, that is for interface hierarchy. So we have abstract collection at the root of your class hierarchy. Okay, so that means collection classes are set of classes which are, some of them are abstract classes and some of them are concrete classes, which directly extends the abstract class. Okay, so we'll see one by one and then we'll discuss about them one by one. Okay, so wherever you see abstract, they are all abstract classes, and wherever you don't see abstract, they are all concrete classes. Okay, and so at the root of collection classes hierarchy, we have abstract collection, which implements most of the collection interface methods. So we've seen what are the methods that are declared by collection interface in yesterday's session, last session. Okay, so then we have three categories or three behaviors that extends collection. That is your list, which is a sequential list of items, and then you have queues, which implements first in first out behavior, and then you have sets, which is used for unique objects. Okay, to collect unique objects. So abstract list is a which implements a list interface, but by extending abstract collection. Okay, it implements list interface as well as it extends from abstract collection class. Okay, so that is your abstract list, extends abstract collection, and then implements your list interface. Okay, so you have abstract sequential list, which extends abstract list. Okay, for sequential access of collection of our group of elements. Okay, group of objects. We will see all these things in an example. Then it makes sense. Okay, so then linked list and array list are concrete classes of your list interface. Okay, that is your linked list. It implements the abstract sequential list for sequential access of your elements, which basically is linked, which implements the linked list data structure. Okay, if any one of you are aware of C++, you'll be knowing what is a linked list. Okay, so that is like accessing each list. You connect each list through memory allocations, and then you access them through different ways. There can be different kinds of linked list, circular linked list, single linked list, all those things. Okay, so that is what behavior is being implemented by this particular class, that is linked list. Array list implements dynamic array, which is nothing but dynamically you can assign objects or store objects in array list, and you can remove or remove the array list so that it shrinks. It either grows or shrinks according to your needs. So that is what is your dynamic array or expandable array. Okay, and then you have a set interface, which is implemented by abstract set by extending abstract collection abstract class, and enim set, it is also, it extends abstract set, and it is used to work with your enim elements. Okay, we know what are enumerations. Okay, apart from those things, we have hash set, which extends abstract set, which implements a hash table, which just stores elements in the form of hash table. We'll see what are those hash tables. Okay, it is nothing but hash table is nothing but it stores values in the form of key value pairs. Okay, key is generated using something called as hashing. Okay, and linked hash set, it extends hash set, but it allows you to iterate your elements that are stored in the collection in insertion order. That is how you insert, the order in which you insert elements in a hash set. In the same order, you can iterate over it. Okay, we will see those things. And tree set, it implements abstract set, but it stores elements in sorted order, in ascending order. Yes, correct. Yeah, Pawan is telling best example of hash table is the dictionary. Okay, we'll see all those things. Yeah, if you have additional information, you can explain it to all of us, Pawan. Okay. Then we have one more interface, that is queue. Abstract queue implements your queue interface by extending abstract collection in class. Okay, so when you see all these things, you'll notice that whatever the methods that are available are declared in your collection interface. Most of them are implemented by your abstract collection class. Okay, because abstract collection implements collection interface, and this abstract collection class is extended by most of the classes. Okay, almost all the classes that are there in your collection framework. And priority queue extends your abstract, but supports priority based queue, which you provide it through your based on your comparator. Okay, just wanted to let you know all. Probably I may not be able to complete collections or your util package today only. Not today in this session. We'll have another evening session also. We'll continue with our util package. Okay, it's a bit bigger package. Okay, in the sense like we have to know a little more about the classes and all those things that are in your util package. So we'll have another session for your threads. I'll let you know when we'll have that session. Okay. So all these things are some of the important classes in collection. So these are the relationship between the class hierarchy. This diagram shows the class hierarchy. So here you see like the dotted arrow is your implements, and then solid arrow is your extents. That is class extents, and a particular class implements an interface. Okay, you can easily make out interface, and then others are your classes. Okay, we have another section that is your map. We will discuss about those things in our next session. Okay. And there are some more classes which are legacy classes, like your hash table, vectors, yeah, this one, and then a few more are there. We'll discuss about all those things. Okay. Okay, let's get started. So we'll start with the array list class. Okay, array list class is a concrete class which extends abstract list. Okay, and implements list interface. So as we know, most of the classes which are there in collection is generic class. So the declaration of this particular class is array list, where you specifies the type of object which are stored in your array list. Okay, as we just mentioned, it supports dynamic arrays. Okay, it grows as well as it shrinks as the objects are added and removed. Okay, that is why it is called as variable length array. Array, you can say. So as it is dynamic arrays, means like it can grow and it can shrink as the requirement arises. Okay. So where do you use basically this array list? Say for example, you have arrays also in Java, right? They are all of fixed length. When you create an array object of any type, okay, you specify the number of elements that you are going to store in that particular array, right? Once that is fixed, you will not be able to add more elements, or it will not grow as such. So it is of fixed length. But in case of array list, it is not that kind of, I mean, it is not like that. Even though it starts with the certain size, it can have, when you start approaching the size of the particular array, you can, it grows automatically. And when you remove some objects from the array list, you can shrink it to the number of elements that are number of objects that are there in the array list. Okay. So these are some of the basic constructors that we can use with the array list. Okay. So here the first constructor creates an array list which is empty. Okay, which is empty. It will not have anything. When you try to call a method which is empty method, it returns true because no elements will be there. Okay. Our second constructor will create an object which is populated with the collection that you specify as parameter to the constructor. Okay, argument to the constructor. And then array list, third one is you can specify how many allocations should be there as soon as you specify. I mean, as soon as you have your array list object created. Okay, so that before you start allocating or assigning objects or storing objects in array list, you'll have enough number of memory allocations allotted for that, and then once it starts reaching that capacity, it starts growing. Okay. So where do you use it? I mean, like there may be situations where you may not know the exact number of elements that needs to be stored during runtime. Okay, we are not talking about anything here at compile time, but during runtime, you might query something and you will not know how many objects that the query will return, which you need to store it in some collection. So if you and also like after querying, and you might add some more objects to it. So you'll not know by initially when you are trying to create, right? You'll not know how many objects you needed, but you read it and then you query and then add all the objects to that particular array list, and then you start adding some more objects to it. That is when this particular array list will become very important. Okay, so because after creating the array list, you can grow or shrink as needed. Okay, that's what I mentioned here. The size is exceeded when the size exceeds, the array list is enlarged, and when you remove it, it is shrunk. Okay. So let us see an example of array list here. These are all very simple examples. So let us try to understand all the methods that we have seen in collection and other collection as well as list interfaces. Okay. So here I am using the default constructor, that is which does not take any arguments, which does not define any parameters to it. Okay, so it creates an object with the empty list. Okay, it will not contain any of the objects. Okay, so you can yesterday when we were discussing, we were comparing these collections with some containers, right? Some containers which can hold the objects, any type of object. So as we just discussed, array list is a generic class. So you have to specify the type of object that you are going to store in array list. Okay. So okay, Pawan is asking a question. When we use array list int capacity, that is our third constructor here. That is our third constructor. He has a question on that. Is the size of the array list variable? Yes, obviously. See, it is a what is asking is when we specify this and create an object, is the size like whether the array when the capacity that is specified approaches, or if it is full. Say for example, you specify 10. Okay, you want and you have 11 objects to be stored in array list. So after storing 10, will that grow? That is what is this question. So obviously it will grow because array lists are dynamic arrays. You can it can grow and it can shrink as and when it is required. Yes. Yeah. Kavita says yes, correct. Yeah. So let us see an example. Okay. So here we have used a default constructor and it creates an object with empty list. Okay, whatever the list that you have, I mean, it is no objects will be stored in that. We will start storing them by using add methods that we discussed yesterday. Okay, so here if you try to, so that we discussed yesterday that size method will give the number of elements stored in your or number of objects in a particular collection. So list is also a collection. Here we can store strings because the type parameter that we have passed here is string. For that matter, you can specify any other object also, any other type also. Okay, that is what I meant. But you cannot specify primitive types. Okay, we discussed that point when we were discussing about generics, right? And the collection framework works only with objects, not with your primitive types. Okay, that is an important point we should remember. So soon after you create with the default constructor, when you try to invoke the method is empty. Okay, is empty. This will return. This particular method will return true if a particular collection does not have any objects stored in it. Okay, if it has any number of elements, it will return false. So it is like querying the collection, whether it is an empty collection or not. Okay, if it is empty, it will return true. If it is not empty, it will return false. Okay, the size, it will return number of objects that are stored in your collection. Okay, so now we will move on to the third method. So that is your add method. So in order to add any object to a collection, here we are discussing about list, which is array list. So we use different methods to add an object into a collection. We have different kinds of methods. One is your add method that is defined in your collection interface. Another one is add all. Okay, that is also defined in your collection interface. Okay, but we are discussing about list interface, which extends collection interface. And when we were discussing yesterday, like we will have a list which is index based. Okay, I don't have the pen. Okay, so which is index based. List is index based. We can query based on those index. Each object, which are all stored in your collection array list for our example, you can query them or you can retrieve them using index, or you can add elements into it or objects into the array list based on index. Okay, we will see some of the examples. So here we are not using any of index based additions. Okay, so based on the index, you have a couple of methods defined in your list interface. That is the overloading of add methods. Okay, whatever the add methods that are there, they are overloaded to include index. First parameter will be index, and second will be the object. Or first parameter will be the index, second will be a collection of objects which you want to store it in your list interface, or list object for that matter. Okay, so here I have added three objects, 3 strings, 1, 2, 3, and after adding 3 strings, I'm again calling size method. Okay, so how much should the size return here in this particular case? It should return 3, right? Because it has 3 elements. We have already added 3 elements to it. Okay, so notice that we have not used any of index-based additions here, so we can do that. Okay, let us do that after a couple of minutes. Okay, so what are we trying to do here? So we know that each we are talking about list objects, right? Which is our array list. Okay, so lists are index-based, so we can have a particular for loop with an index they define, and you can get those objects. Whatever the objects that are stored in your array list, you can get them using your getter method by passing the index. Okay, this is your get method, which can be used on your list. Okay, it can be used on your list, any list. Okay, we are talking about array list, linked list, and all those things. Okay, so here we are talking about array list. So you can use get method to retrieve an object on a particular index. So we are passing index as this particular counter. Okay, so it starts with 0. So as you know, the index starts with 0 for your arrays, for your strings, and for your lists. Okay, it always starts with 0. So if you want to get any object, for example, 3 we have added, right? Here the index of 1 will be 0, 2 will be 1, and the 3 will be 2. Okay, so if you want to get an element which is on index 1, you can use get of 1. Directly you can specify an integer or index number. Okay. So here we are trying to access them within a loop, which will give all the elements that are stored in your array list. Okay. And since we will discuss about that iterable interface. Okay. So we have one particular interface which is called as iterable. Okay. It has one method called iterator. It has one method called iterator. Okay. So this particular iterable interface is implemented or extended by our root interface collection. Okay. So this particular method is available on all the objects that are part of your collection framework, because collection extends iterable interface. Okay. Collection extends iterable interface. That is why all the objects that are part of your collection can be iterable through your iterator. So iterable or iterator is nothing but you want to get each and every object using, one by one, which are stored in your collection. That is what you can call it as enumeration. Okay. There was one more interface which was called as enumeration, but that is taken over by this particular. Now we no longer use that.
Muted.
Available in your iterable interface, which is extended by collection. Okay. And this method, when you call iterator on any of the object, this will return an object of type sorry, I'm not sure how to write it. So okay, it will return an object of type iterator. Let me open the API. That will make a lot of sense. Or I'm opening the IO. We are in util package, right? So this is our collection interface. So it extends super interfaces your iterable. So here we have it declares one particular method, that is iterator. So it returns an iterator to iterate over a particular collection of objects. Okay, that it returns an iterator object. Okay, this is your iterator object. So this particular iterator interface defines few more methods to kind of like go over all the objects that are there in your particular collection. Okay. So we'll discuss about this first before we go to other classes. So it has this is our iterator interface. Okay. So it declares, this particular interface declares 3 methods. That is has next. I'm not sure whether you are able to see this. Let me open it in this. I hope all of you can see my screen now properly. So now we have this particular interface declares 3 methods. That is your has next, and then remove. Okay. So as the definition tells, it returns a Boolean value. Okay, it returns a Boolean value which says whether so say for example you have got an iterator object for array list, which we are discussing now, and you want to kind of like see which are all the objects that are there in your collection, array list collection, okay? And you want to use iterator object. I'll show you how to use those things, okay? Before that, let us discuss this. So you want to iterate over the objects that are there in your array list. So you get a iterator object using iterator method on iterable interface, okay? That will give you an iterator object. So on this iterator object, you can use any of these methods, okay? Any of these methods. So when you use has next, okay, when you use has next, it returns true if the collection has more elements to be iterated, okay? If it is true, you can call next to get the particular element, or if you want to remove an element, you can use remove method, okay? So let us see. So we have three methods on iterator, that is has next, next, and remove, okay? So we will see how to use has next and next method to iterate over your collection to retrieve the objects that are stored in your array list, okay? So without your iterator also, you can use this way, but this is allowed for your lists, because the lists you can use on lists you can use indexes, right? The indices. You have each and every object associated with a particular index. So you can use for loop to get a particular object on a particular index, like we have done here. And since collection interface itself extends iterable interface, they are we can use for each for loop, that is a new for loop. Earlier this particular for loop was not there, but since JDK5 this was introduced, okay? So this for loop we can use it. So notice that how we have used this for loop, and it looks so simpler compared to this one, okay? We'll discuss about that as well, okay? And then how we can iterate over the objects that are there in your array list using iterator, okay? So let us discuss about this first. So since we have declared an array list which can store string, what exactly happens here is we have specified this particular collection my list, which is nothing but this one, okay? We have stored a number of objects in this, and then that is the list. So what exactly this for loop does is it iterates over each object in my list, okay, and assigns that object to the string. For example, if you have any other thing, object here, that is our integer object, integer object, not primitive type. So you can specify one particular object here, object or primitive type int here, and this for loop will take one object at a time and assign it to the variable that you have declared here, and that we can use it for any of the processing that we have. Currently I'm using it here to display what is the particular string is, okay? So there is one particular we know how important toString method is. Okay, after so default implementation of toString is to display the elements here, okay? So we know how to override the toString method, and that particular method is overridden for all of the collection classes, collection objects, okay? So the default implementation is it lists out all your objects that are there in a collection within your square brackets, okay? You can just say my list, okay? So that will list out all the objects. So now we can see after adding 3 elements, this should give us 3. Here we are trying to print the index and the object itself, and here we are using the new for loop, and then here we are using iterator to iterate over each object. So if you notice here, we have used 2 methods, that is has next, okay? So as long as this particular method returns true, while loop will be executing this particular command, okay, this statement. So here we are using next method, okay? So this will return the, if has next returns true, that means it has, the collection has more elements to be iterated. Okay, so that is why when you call next on after has next returns true, it will return the next available element which you can take out and then you can process it. Okay, so here whenever you call next, it won't remove the element from the collection. Okay, so it just gives you the object. Okay, and then you have one more iterator which is specific to your list interface. Okay, so we have list iterator. Okay, what is the advantage of using iterator and the list iterator? So here you can, from the start, right, from first element, from first index to last index, you can query for objects. You can query for objects. You can request for objects, but you can't go once you reach the nth. Say for example, you have 10 objects in a collection in my array list. Okay, in my list you have 10 objects. Okay, and you have retrieved the 10th element. You have retrieved 10th element, and when you try to run has next, it will not return true. Okay, so from there you can't iterate back to your top element, that is first element. Okay, that is your iterator, but list iterator enables that part because it defines a couple of a few more methods through which you can, once you reach to the last element, you can go back. Okay, in reverse order. You can go back in reverse order and print whatever the objects, or if you want to verify whether at a particular index you have a specific object, you can use this particular iterator object. Okay, list iterator object. So it defines some of the methods like has next. Let me discuss about this first, and then we'll go to the explanation of the method. Okay, list iterator. Remember, you have in iterator you have has next, next, and remove, and see how they are related to your list iterator. Okay, so here you can add an element with your add method. Insert a specific element into the list. Okay, this is an optional operation. So similarly, your iterator, it has next. Okay, and then next, and then it has remove methods because it extends iterator. Okay, then apart from those methods, it has previous, which is similar to has next. So assume that you have reached the last element. Okay, and when you try to do has next on iterator, it will return false. But when you try to run has previous on your list iterator, it will return true because it has the pointer. If you can say pointer, it has the previous element. This is the last element, but it has previous elements. That is when you use this previous has previous, as the name itself indicates. Yes, correct, Kavita. Yeah. So Kavita seems to know Util package well. So okay. So in so I'm trying to have one just let you know. I'll try to have one particular session dedicated for clarifying doubts. Okay. So if any of you wants to kind of like give kind of presentation on any topic, any topic that any topic of your interest in core Java, you can prepare that particular topic and try to give some presentation. It may not be like 1 hour or something like that. Even if it is for 10 minutes, right? It's well and good. Okay, you can prepare your slides and you can explain what of your interest. It could be whatever we discussed in the till so far in our all sessions, or it could be something we have not discussed at all, or something which is interesting to you. Okay, so if anybody wants to do that, they can do it. Okay, so we have has previous, and similar to next, we have previous to get the previous element. Okay, and also we can get the next index and previous index of a particular object. Remove and set. It set is nothing but it sets at a particular point. It sets the element. Replaces the last element returned by next or previous with specified element. Okay, the next element or the previous element that is pointed by the iterator, it sets the value to the whatever the value that is specified in your set method. Okay, so remember we have the previous set add method here these are the 4 extra methods that are available in your list iterator, apart from what are the methods that are available in your iterator interface. Okay. So here what I'm trying to do is I got list iterator for my collection, that is my array list. Okay. So here also it has to be specified as string because we have a string object stored in my list array list. Okay. So what I'm doing here is similar to what I did here. That is, I'm iterating each object from top to bottom. Okay. After reaching all the elements, I'm trying to iterate in reverse order. Here I'm trying to get all the objects in reverse order because I've reached the top, bottom. I mean the last element that is stored in your my array list. Okay, my list, and then I can use previous and has previous methods to iterate back from your last object. Okay. When we run these things, we will try to analyze the code part as well as the output that it gives, right? And then we have some methods which to convert a particular array list to convert an array list into an array. Okay, convert an array list into an array. Okay, this is how you do it. You you create a particular string array because the objects that are stored in your array list is string. You call this particular method toArray, and you can pass this. You can pass that as an argument to toArray method, which will be stored. Okay, this will also return an array list. Okay, which it will also return an array. That is what we are trying to store it in this particular array itself. We can have a different one also. So you can so whatever we are trying to do is we are trying to convert all the objects that are there in my list into an array. Okay, after converting that, we are printing it as we did with arrays. Okay, list array, or we can use dot length while using with your for loop, like okay, yeah, with this particular you can print this way because this is an array, right? You can print this way. That is our normal array operations. Okay, so let us try to run this program and try to understand all these things, and we will after running this program, we will try to explore few more methods that are defined in your collection as well as the interface, list interface. Okay, so let us go here and compare the output with each statement here. So we have created array object. Okay, and then we are trying to list out the number of elements that are stored in your array object. This is the default constructor. That's why the number of elements stored is 0, and when you call is empty, it returns true because at this point excuse me, the array list is empty. Okay, that is why it returns true. So now then we are trying to print the then we have added 3 elements and we are trying to print the array list itself. So this is how it prints. The two string methods for all the collections objects are overridden to display the elements in this way. Okay, there are we have added 3 strings. Okay, 3 string objects in my array list. That is what it is displaying within your square brackets. So if you have any other, if you want to store any object which you created, you can also store them. But if you don't provide any 2 string method for your class, whatever the object that you created, here you will be able to, and if you have stored those objects of whatever the object that you created, you'll be able to see all the references here, object references here. Okay, so I'll show you an example. And here here we are printing sorry. So here we are printing the array, the object within a particular array list, and then after adding, we are trying to print the size. So it should give number 3, right? So it is giving current size after adding. Okay, then after that we are trying to print the objects within my list using for loop, which prints this one. Okay, then we are trying to print using the for each. Just use this one. Okay, then we are trying to print the objects using while loop using iterator that gives this, which is same whatever we discussed. Okay, and then here if you see, we are trying to display the objects using list iterator. After all the objects are displayed, we are trying to display them in reverse order using has previous and previous. Okay, so you can see here, first 1 will be printed, 2 and then 3. Okay, so after that we converted the array list into an array of string, and then we try to print the number of elements in list array. We are not trying to print the elements in your collection. We are trying to print the elements in your array list array. Okay, using the field length that gives you 3. Okay, then you can iterate through because arrays are implemented as objects in Java. That also implements triple interface. So we can use for each for loop to iterate over your array. So which using which I have displayed the collection objects. This one. So there are other methods. Let us discuss one by one. So now if I want to add, excuse me. So if you see this, right, so if you see this one, the index of at index 0 we have string 1, at index 1 we have string 2, at index 2 we have string 3. Okay, so if you want to add any element at the end of this particular collection, that is your array list, you can very well use add method. Okay, so what we can do here is 4. It is add 4. Okay, so then when you try to print the values, you will try to use the default one. Okay, so let us try this one. Let's see what is the output. Okay, so you can see at the last, the 4th element which we added just now is added. Okay, so if you try to print the values, so it will show these things. Okay, or it is better to have this one because we can print the index as well. Okay, so index 0 we have 1, 1, 2, 2, 3 and 3 and 4. Okay, now I want to add something in between on 2 or 1 or 2 index. Okay, so what I will do is, this is overloaded method provided by your list interface. Okay, add my list dot add we can specify I want to add it to the index 2 and you can specify 5. Okay, now when I try to print this, it is interesting to see what exactly happened. Okay, so now if you try to print it, okay, let us give so now you can see I added on index 2. So okay, so someone has a question. Yeah, give me a second, Pawan. Let me explain this particular part and then I'll hand over to you. Okay, so the index of 0 is at index 0 we have 1, at index 1 we have 2, at index 2 we have 5. This is important to note because we have added 5 to index 2. Okay, it takes the literal meaning of 2. That means it adds to the index 2. Okay, and then you have on index 3 you have 3, and 4 you have 4. Okay, this is how you can add an element to your list using your index. Okay, so let's go to Pawan. Yeah, Pawan, go ahead.
Actually, when we're using the get method and the has next method, the output are the same, right?
Get method and has next, is it? Yeah, you are trying to see here. You are trying to use get method, right? Yeah, get method you are trying to use it. Okay, so you can't use this get method without index. You can't use get method on any other objects apart from your list. Say for example, you have sets, you have queues and all, right? You cannot use get with an index I. Okay, because they are not indexed collection. List is our indexed collection. List is our indexed collection, and has next. It is we are trying to access elements or objects in a collection using iterator. Iterator or list iterator. Okay. If you want, if you want to access objects in your list using index, you can go for get, or without anything, you can use your for each loop for loop.
Okay.
Okay.
Yeah.
Okay.
I have one more doubt. Okay.
Yeah.
And has previous. Okay. When you talk of has previous. Okay. When we initiate the has previous, so how does it start printing from the end?
Okay, so for example, let us assume this way. Unfortunately, I'm not at my place. I came to, not unfortunately, unfortunate for you all. Maybe I can say, because I forgot to bring my pen using which I used to write, right? So that is why I'm finding it difficult to explain it in a better way. Okay, say for example, you have okay, so here you have, so let us take with the 0, 1, 1, 2, 3, 4, 5. Okay, assume that you have 6 objects in your list. Okay, and you retrieve an iterator to iterate through these objects. Okay, so initially assume, it is just an assume how they have implemented. You can try to Google and find out. Okay, so say that you have a pointer pointing to your first object.
Okay.
Yeah, correct. We have remove method also. Kavita is telling we can use remove method to remove elements from the collection. Yeah, we can use that as well. Correct, Kavita. Okay, so we assume that you have a particular pointer pointing to your first element.
Okay.
0. Okay, once you read using your next method. Okay, at this point, if you call has next, right, on this collection, has next on this collection, this will return true because you are at this point and it sees this particular object and it returns whether it checks whether there is a next element, or it checks this particular element and see whether an element actually exists or not. Okay. So you see that that particular list is not empty and you do have next element, right? So it returns true. Then you can call next on this pointer, which will return actually this first one. Or you can say the pointer is pointing to here. Pointer is pointing at this point, and when you call next, okay, when you call next, it will see this particular object and it returns true. And when you call next, it returns the actual object. Okay, then the pointer is moved to this particular element, and again when you call next, it will see this object and it says true. And then when you call next, the pointer is moved to this one and this particular object is returned. Okay, so by the end of this one, right, the pointer will be pointing to this point, this location.
Okay.
Okay, and when you call has previous on list iterator, not on iterator, list iterator. Okay, so it checks whether previous elements are there, it returns true, and then when you call previous, it returns the first object. Okay, and then the pointer moves in reverse direction. Okay, it does not mean that you have to call previous method at the last object. You can immediately after the first one, you can, if you try to call has previous here, it will say true, and we can return the objects using your previous method. That's how your iterator works. Okay.
Okay. What if I don't use the has next at all in my program? I directly use the has previous.
Directly you want to use what?
Has previous.
Has previous. Okay, let us try that one. Okay, so let us see what exactly happens. So let us see here, here itself. Okay, so I have not initiated this one with anything. Okay, so let us try has next and has previous for this particular list, because now we don't have anything here, right?
Yeah.
Okay, so let us try here. Oh, sorry, we can't call on this thing. I was thinking of something else. You can call them on iterator object. So let us call on, okay, let us get the iterator on here itself. Okay, let us do this one. We are not called previous here, right? Okay, sorry. Yeah. This is what is causing. Has previous, not previous. Has previous. Okay, now you will not get any exception. Okay, so this is how it happens. Okay, so here you can see this is what is our previous object. Previous object. So let us do the same thing here at this point. So now you'll see all these things. Okay. So here what is happening? Like you are checking there are no elements, right? So you are checking it will return false because it returns boolean, right? So when no elements are there, when you try to check whether next object is there, it returns false. And even when you try to call has previous, it will return false. Okay. So let us move to the. Let us try to add one object. Say for example, you have has next. Okay, so you read one particular object. Okay, what you want to do? So after adding, let us try single methods. Okay, here it returns true. Okay, then what we can do is okay. So we are next object it should give right. Sorry. Okay. Okay, we have not got the object here. Let us try this one. Okay, so now it will give the object. So other things will change accordingly. So we will see those things. Okay, next object is 1. It gives the first object. Okay, now after calling this, let us try to print what has previous returns. Okay. Okay, so here we are at this point. Okay, so this will return true. It has next object. So we are printing the object, first object, and then we are calling previous, whether previous object exists or not. Okay, so it returns true. Previous means it returns 1 only because the pointer, it is pointing to the previous of what the pointer is pointing. Okay, it moves to the next object, and when you try to query, right, it will point to the previous object, and then that is why it shows when you try to print it, it prints the 1 only. So both are printing 1. Okay, that's how your list iterator has previous and iterator methods has next, has previous, and next will work. Okay. Any other questions, Pawan or anyone else?
No.
Okay, some important things or interesting things are there which Kavita would like to share with us. Yeah, Kavita, go ahead.
No, because while I mean, we were trying this this problem, like we got some concurrent modification exceptions. So I mean, usually there is a question that is asked like whether the iterator fails fast or fails safe. Like so, sometimes like fail fast. Like I have that understanding that it gives an exception. It shows an exception, but fail safe, it doesn't shows exception, but they want more explanation. So how can we explain this concept, fail fast and fail safe? It is always related to iterator.
Okay, so I'll discuss that later, Kavita. Okay, what my point right now is, we will try to finish whatever I have in my slides. Okay, so I'll try to finish that. If we have time, we will discuss about that. Otherwise, we will start with your topic first in our next session. Okay, is that fine?
Yeah, that is fine. But this we got when we are doing some changes. Why we got this concurrent modification exception?
Maybe we have called one of these methods on the empty list. Say for example here, right? Say now if I want to call no such element. I did not observe that part. We will see that one later, Kavita. Okay? We'll discuss about that later. Okay?
Yes.
So yeah, we'll discuss about that later. And yesterday I had told one more point that was related to yesterday first class. That is related to static thing, right? When we are trying to when we were trying to serialize static objects, static instance variable, it was trying to print, but when we try to open the serialized object itself, which we stored in a particular file, that particular object was not there. Yeah, we'll see that one. That both of these things I will try to explain it in next
No,
session.
I
Okay?
have some answer for this. I don't know it is correct or not for that serialization. I mean, because serialization saves the state of an object. So my understanding is that it only saves the values, not the methods or anything like that. But when we are using the static, we are not actually storing that object. So it's belong to the class. So the static variable, whatever the value, is not stored there. But when we deserialize, it is getting the value from the current class, which gets loaded while you run the program. I don't know. It may
Got it.
be.
Yeah. I think whatever you're talking is whatever you're talking makes sense. Correct. So we understand that static belongs to class, right?
Yeah,
It is not specific to your
to the
object.
object. Yeah.
Yes. So when you try to, I mean, like whatever the object that you create, that object will have a copy of your static instance variable, and that object obviously that static variable will have that particular value, whatever you have assigned it when we discussed about yesterday. So all the objects, whatever the object that you create, that all those objects will have a copy. If you assume it that way, will have a copy of this particular instance variable, which is static, which is global. Okay, so that is why when you read it from your serialized file or serialized object, it actually created. Okay, so it may be like this. Say for example, the moment you created an object and assigned the reference to it, that already had one particular value for this static, which it got it from the class definition itself. That's what you also meant, right?
Yeah, that's what
Yeah,
I mean.
correct.
Means the
Yeah, that
difference
makes sense.
between the transient and the static is that you retrieve the value after deserialize in static, but in transient you get 0 when you deserialize that. I mean,
Yeah,
that's.
because for transient you will not be able to say the state of the instance variable. So obviously, when you don't specify, the default value will be assigned, and since it is not saved, the default value is what you get when you try to print it. But for static, obviously, it gets it from your class definition itself, right? Each and every object will have that the definition. Yeah, whatever you told is perfect, Kavita. So it makes sense.
Yeah, means I wanted to tell on that day, but something wrong with my computer, so I was not able
Okay.
to chat anything.
Okay, I mean, this GoTo has a few things. I mean, it comes. I mean, we had a few issues, right? Whenever I mean, we had some issues. Like there are a few bugs. It says so. Either it affects the audience or it affects me. So who is training? So one of them will be. I mean, like I am not sure whether when that will happen or what exactly is the issue or. So we have seen those issues previously also, right? We can't do anything with those things.
Yeah. No, I think it was problem with my laptop. Yeah.
Okay.
Something.
Okay. Now,
Yeah.
Hugh has a question. Let me take up that question. Sure, Kavita. Let me take up that question. Yeah, Hugh. Hugh. Go ahead, please.
No, what I wanted to say is that static variable does not get serialized at all, because if you, let's say you initialize a static variable and you serialize the object, if you change the value of that static variable before you deserialize and then you print it, you're going to see that you get the new value that of the static variable. So it does not get serialized at all.
Exactly. That is what we were discussing here. So yeah. So whatever you told is correct. So when you try to serialize it, you will not be able to serialize the state of static variable at all, like it is done for your transient variables. But when you try to print it, you will get the value of the static variable from your class definition itself. So if you try to change that value, yeah, if you try to change that value using, if you have, for example, if you have some getters or setters methods, if you try to change it, whatever the value that you assign it to that static variable, you will get the same value. Obviously, what you told is exactly correct.
Okay.
Does it make sense?
Yes, yes.
Whatever you told, I told it. Yeah, whatever you mentioned, the same thing I have put it in different way. That's it. You can change the value of a static variable. So when you change it, you are changing at class level, not at object level. So obviously, the object that you got from your deserialized state, that will not have your static instance variable, but that it gets that from your class definition. That's what I meant. Okay.
Yes, yes.
Okay. Yeah. Thanks for your information, you, and thanks, Kavita.
Okay.
Thanks a lot.
Okay,
Yeah,
thanks.
Yeah, we were here, and yeah, we were discussing about that exception, right? So I'll get back to you on concurrent modification exception in next session, Kavita. Okay, and we will try to simulate that scenario, and we will try to explain fail fast and fail safe. Okay, on iterator. So these are some of the methods, and we have few more methods. So I mean, one more thing I would like to mention is I would encourage all of you to have these sessions interactive. So in that way, we will, if I don't know something, I'll try to get that information and share it with all of you, right? That will be a better way to, for me also to understand and for you also to understand, right? For new things. Okay, so we have few more methods. This is one of the methods that we used just now. So let us try to comment out whichever is not needed. Okay, so all these things. Okay, so let us run this program so that our output is small. Okay, so here we have added with the index, and you can see file is added to that particular index. Okay, so now if we call it will give false. Okay, and then what other methods we have? So you have added one particular object. Let us create one particular collection. For example, string array list string sublist is equal to new array list of, okay, and then add some elements to it. Dot add. So since these are all basic methods which you should know, I'm trying to explain it. I'm trying to take more time to explain it because this is common for all other classes as well. Okay, and we will try to discuss specific methods for specific objects. Say, for example, your set objects or queue objects or your list objects. Okay. Okay. So let us add. Okay, so we will try to add this. We have this one. Okay, so we will add this at index. We will use add all and specify the index where it wants to be. I mean, where we want it to get inserted. Okay, my list dot add all and list. Okay, this will add all these elements at the end of the existing list, but I don't want to do that one. I want to specify the index from where it needs to be added. Okay, so say for example, I want it after first. Okay, first index. From first index, it will start adding. Okay, then let us try to print. Let us not have this. Let us try to print this. Okay. So now you can see from 1, 6, 5, 7, 8. This is not what I was expecting. Okay, sorry. It was here. Okay. Okay, let us run this. So you can see now. So from 1, 6, 7, 8 is added, and then 2 is pushed down. Okay, 2 is pushed down to your index 4 now. Okay, earlier 2 was, 5 was in your, why this became like this? Index 2 is 5. So 1, 1, 2, 5, right? Yeah, correct, obviously. So your index 0 has 1 and 1 had 2. Okay, 1 had 2 and 3 had, let us print that one here before we add. That will make sense to compare before we added the collection itself. Okay, not here. Let me add it here. Okay, so earlier before adding the collection, we had this list. Okay, 0 had index 0 had 1, 1 had 2. Okay, after adding index, the collection, sublist collection, we are trying to add it to the index 1 from index 1. So that is why it started adding 6, 7, 8, and at 1, whatever was there at 1, that is 2, that is pushed down to index 4. Okay, 2, and then index 5 became 5, 6 became 3, and 7 became 4, right? And then if you want, there are other methods. Let's try to check whether a particular object exists or not. Okay, I want to check whether the 5 exists. Okay, then we will remove one particular element. Okay, let us add one more element. My list dot add. What is okay? Let us add one itself. Okay, and then we will use so it does not mean that you can use this particular array list only for only with your string. So we can pass any type. You can use all these methods on any of the type that you pass in while creating your array list object. Okay. So I'm hoping that you understood that point. That index of, okay, because we have duplicates. So as array lists allow duplicate values, last index of okay. So now let us start we have contained, okay. So now we have some methods which can remove an element. My list and let let us remove one particular object, that is yours. Do we have 8? Okay, so let us remove this particular object. So we have not specified any index here. We can also specify index. Okay, so index, say for example 3. I want to remove some element, and I want to remove this particular list. Excuse me, sublist. Okay, remove list. So what I can do is list remove. We have to use all. Okay, so I can mention list here. Okay, and then now, so return list is like it will return all the objects that you have specified here and removes all other objects. Okay, so list dot retain all. Retain all. So we can specify retain list. Okay, so what we can do is let us have string only, and list dot get. Okay, so let us try to print after removing. I'm trying to print this particular list, that is my list. Okay, and why is it giving error? My list is of type print only, right? So let us remove this time. The method print list from type array list test refers to the missing type list. So what do we need to do now? And then string, you can't mention string here, right? No. So how do we do this one? Does anyone know? I just want to print these things with a method. Can anyone tell? Yeah, Kavita. Yeah, go ahead.
I mean, it cannot print object or what? ToString or? I mean,
No. I want one particular method. I'm passing the list, okay? And then this should give, as far as I know, this should give because we have initialized with the string, right? So even if we specify, say here, we have specified a string, right? So even if we specify, once we specify, even in, if we just mention my list, it should take here with this or without this. That is what my understanding was. But this cannot be resolved to a type. Okay.
can we
So
make
that is
array list? Array list.
No. Sorry. It is this one. So I did not read it properly. Okay. So now it should work here. It should not give any error now. Okay, let me make this as a string so that we won't get any issues. Okay. So 7. Yeah. After this, we will print this. Remove add list. Okay, sorry, not here. After this. And after retain list. Okay, we will try to print it, and each time we will try to okay. So before we try to remove anything, this is what exists. Okay, and where did we add one here? Index 1 here. Okay, we have all the elements now. So 1, 1. So we are trying to print the index of. We are trying to use the contains method to check whether 5 exists or not. Okay, so it says true, and then we are trying to see whether 10 exists or not. Okay, so that is when it says false. Here it says false because 10 does not exist. Okay, the index of first index of 1 is 0 because this is the one we are searching for. The last index of 1 is this one, so it gives the index of that particular object. Okay, so what did we do next? We have removed a couple of elements, I guess. Yeah, we removed 6 and 7, so we should not be able to see 6 and 7 in our list after removing. Yeah, here we can't see 6 and 7, and then we removed. Yeah, this is as a list. Okay, remove list. As a collection, we removed it. Okay, not individual. Here we are removing individual elements. Okay, but here we are removing a group of objects from your collection list itself. Okay, that is 6 and 7. And then here we are returning only 1, 2, 3, and 4. All others are removed. Okay. Okay. So. Okay. So at the last, when we try to print this, execute this statement, this is what you are able to see, because we have returned only 1, 2, 3, 4, and all others were removed. That is 1, 4, and 3. Where is okay? So 4 elements are there. 2 is not there. So 1, 1, 4, and 3. 8, and 5 are removed from this list. Okay. This is how it happened. The final list is this one. And if you want to clear the entire collection, you can use dot. Okay. So now if you try to print list after removing everything, it will say nothing. So here it will say nothing. Okay. Okay. After this thing, nothing is there. Okay. So what else methods do we have? I think we have covered most of the methods in collection itself. Okay. Add all, clear, contains all. We can check contains all. It is similar to how we use the remove all and add all. So here it is iterator, remove all, retain all, and size and to array. So almost all the methods we have used it. So here in list interface, we have a couple of methods which deals only with indexes. We have those index. We have used this index of, and then list iterator we have used it. Remove, we have used one particular object to remove. That we have not used. You can you can try to use these two methods on your own and see if you are able to do it. Okay. So let us move on to the next one. That is our linked list. Okay, array list. So you have these three constructors. So I've used only default. Try to use these two constructors as well. Try to initialize, try to have one particular collection and initialize one object. You can do this way. So you have this object, right? You can create an array list. An array list is equal to list of remove list. So you can create this way. That is your second construct. Sorry, not this one. Okay, you can do this way. So I think I don't need to explain these things in much detail. So that's why I'm skipping. Okay. So try all those things and let me know if you have any queries. Okay. Sorry. So to obtain an array from array list, that is what I have showed you to array. Okay. Okay. So here we have tried two array and stored it in list array itself. Okay. And then we are trying to print it. That's how we convert a list into an array object. Okay. Array object. That is what. So there may be different reasons for converting an array list into an array. Okay. Some of the things are like partial processing in some situations. And so if you want to pass to a method which accepts only arrays, you can convert array list into an array and then pass it to a method. And then there are some objects, and now they are integrated into collection framework itself, like your vectors, hash table, properties, all those things. Okay, in such scenarios, you'll be converting it into array. Okay. Okay. So next one is linked list. This is also similar to what array list is, but it stores your elements in insertion order. Okay, in the sense like it simulates linked list data structure itself. It simulates linked list data structure itself. So when you have linked list, you can access those elements in order. Okay. So how you store the elements you can retrieve the elements in the same order. In the sense, like you store elements one after the other, the index will be assigned accordingly, and when you are trying to retrieve them, so obviously you can kind of like retrieve them in the insertion order itself. Okay, so these are your linked list constructors, similar to how we had default constructor for array list. We have default constructor, and you can initialize the linked list object with the collection, whatever the collection you have or you want to initialize it with. Okay, and then since this is generic class, this is the declaration how it is declared. So you can pass the type of the object that the linked list can store in this E, which is a type holder for placeholder for your type. Okay, so one simple example. So I hope it is clear. So I need not have to explain too much about this one here. I did the same thing. String, I've added three things, and since this is also a list, index based, you can add based on your index, and you can add it and try to print it. So it should also give you some results like this. Okay. So you have added 5, which added that object at the last, and you added to a particular index. So you can see, okay, that is 0, 1, and 2. Index to 4 was added. Initially it was 0, 1, 2, and 3. 0, 1, and 2. Okay, 0, 1, and 2. Okay, so let us move on to hash set. So hash set is, it extends abstract set, which in turn extends abstract collection, and it implements a set interface. Okay, so as you know, set interface does not define any of the methods. It borrows all the methods from the collection interface itself. Since abstract set extends abstract collection, so what are the methods that are defined in your abstract collection, those are available, and if it has something needs to be added, that is added in your abstract set. So the important thing about difference about list and set is, list will allow duplicate values, but set you can have only unique values. Okay, so that is what I try to explain it here. When you see here, right? So I was able to add similar objects. Okay, so it allows duplicates. Okay, but when you try to add a duplicate object in set, it will throw an exception. Okay, so abstract set. This is the declaration, how it is declared in your declaration for your hash set. So it stores data and key value pairs, which is called as your hashing mechanism. So key is kind of like generated based on hashing, and that particular key is used for identifying the value associated with that particular key. Okay, you will not be able to modify or access this particular key explicitly. You will not be having you will not be provided access these keys. Okay, you can only access the values, but that is done internally using this hashing. Okay, by Java. So what is the advantage of using a hash set? The execution time of add, retain, remove, and size will remain constant even for large sets. Even if you have millions of objects, if you want to add millions of objects to a particular collection, the execution time for this add will be same for each and every object that you are trying to add. And when you try to remove also, it will be same. And these are things. It has to count when you try to run size, right? It has to go through the whole collection if you have n number of objects, and it has to return the number. Even if you have 10 objects in a collection, it will return the number in the same time. That is, the execution time is same, even if you have a number of objects. Okay, these are your constructors. Int capacity, you can specify the allocations, memory allocations, while you are trying to create an object itself. Okay, fill ratio, just find out what is this fill ratio. Okay, how this fill ratio is used for calculating how many objects that is needed when you kind of like approach the capacity, allocated capacity. Okay, try to find out about the fill ratio. Okay, what does that mean? And if anyone can explain this in our next session, it will be great. Okay, so it, as I mentioned, it does not define any additional methods. So whatever the methods it borrows from your collection interface, those are the methods that are available for your hash set. Okay, so linked hash set, it extends hash set, but you will, as I mentioned, you can kind of like it also maintains insertion order of objects. Okay, insertion order of objects. We can see these two examples. Let us try one example here, simple one. Will not. Okay, Pawan wants to explain what is fill ratio. I'll give you an opportunity, Pawan. Just let me finish it. Okay, so while I am doing this, you can explain what is fill ratio. Give me a second. Where are you? Okay, yeah, you can explain it, Pawan. What is fill ratio? Not able to unmute you. Did you mute yourself? Did you mute yourself, Pawan? No. Okay, I'm not sure. I'm not able to unmute you. Okay. So no, earlier I was able to do it, right? But not now. Let me see. I'm not able to do it now. So when I try to print it, it does not maintain the order in which they are inserted. Okay, so you can see this. This is the order I have inserted these objects. These are all string objects, and when I try to print it, it is not printing it in particular order. Okay, so here also when you try to print it, it is not printing it in order. But when you create a set string with NL set, okay, new hash set of you can initialize this with my set. Okay, and then when you try to print it, this should be able to kind of like provide us the insertion order. Okay, this is how it inserted. So even if you kind of like try to print this, right, it will okay, even if you try to print it with this, it will print it in the same order. Okay, okay, let us do one thing. Okay, so let us try to do this one here. For let us remove this. Okay, so let us try to print this. Okay, so now here it is printing in the order in which we have inserted these records. Okay, so even with this, it meant as the insertion order because it is kind of linked list. Okay, and so that is why we were able to iterate over this particular set in the order in which we have inserted those objects. Okay, that is your linked hash set. And what else we have for hash set? Insertion order. No, that is for queues, right, Pawan? Pawan is asking whether it is whether it implements the concept of first in first out. That is your queues. But there is one more. Yeah, Kavita is telling tree set. Tree set is not like tree set is not kind of like insertion order. It sorts the elements based on the criteria you provide, or by default it sorts in a natural way, in the sense like 1 comes before 2 or A comes before your Z, right? Yeah, sorted, correct. That is your tree set. So it stores your objects in tree form, binary tree or whatever it is. Okay, so let us have okay, tree. Let us see. This is not needed. Let us try to parse this. Okay, not sure whether okay. So let us try to print that and see what exactly has happened to the set itself. Okay, so it has sorted in order. Okay, okay. Let us try adding this in different way so that it makes clear to all of us what is sorting. Okay. So you can see here it has sorted in it has stored in sorted order. Sorry. here you can see that it has stored them. I mean, it is stored in sorted order: E, F, O, S, T, and T. Okay, based on that one: T, E, T, H. Okay, that's how it sorts and stores the elements. So one of the main advantages of using your preset is your like, say for example, you have a situation or criteria where you want to retrieve elements faster, and you want to store it in sorted order. That is when you use your preset class. Okay, so it again extends abstract set and implements a navigable set. So try to go through this particular navigable set interface, and let me know if you have any questions regarding that one. Okay, so as we discussed, iterator interface, we have 3 methods: next, remove, and you have list iterator, has next, next, remove, has previous, previous, next index, previous index. Okay, so I think yeah, I think that is what. So we will discuss about maps in our next session, and try to kind of like go through whatever we have not discussed. Okay, and so many things are there. I mean, if you are all okay, I can have one more session on these things. What is that? Collection interface itself. But if you want me to go to next topic, that is map topic, I will go to map topic. So that again depends on your convenience. So I'm trying to cover this as soon as possible. So if you want more explanation on other things in collection framework, I can do that. Otherwise, I can go to maps. Okay. So what would you suggest? So you can like with I try to explain with array list whatever the things collection framework. Okay, I think that is more than sufficient for you to go through other classes in the collection framework, and then we can. That is what I am thinking. If you have any doubts, please let me know. I will clarify. And in next session, we will jump to the maps part. Okay, so we have something called as maps, and then we'll try to cover rest of the other topics. Okay. Pawan, just a reminder, we had the plan for small discussion in classes, objects, and free basics. Yeah, Pawan, I remember that. I was thinking of that today. So let's see. Maybe not tomorrow. We'll have it on Saturday or maybe on Sunday. Okay, based on your availability. Okay. So you just let me know. You just send me an email when you are available. Not tomorrow, day after tomorrow. Preferably, what I would suggest is, since this will be our one between you and me, it is one-on-one. You can suggest a time. I prefer bit early time, like maybe around 8 o'clock CT or something like that. Okay. So just send me an email, and we can have a discussion. Okay. I'll set up a meeting based on your timings. Okay. Okay. So go through these APIs. Always have this API reference in front of you, and whenever you have some doubts, right, just go through these things. And here they would have given some examples also for some methods which are kind of like need some more elaborated explanation. Okay, and try those things. And if you have any doubts, feel free to send an email to javatraining@gmail.com. And one more thing is, Shravanti had asked one particular question. So that is related to the file name filter, which we discussed during our IO method. Okay. So the question was, we were not calling except method explicitly. Okay. For example, okay, we were discussing about this particular test, and we had this include files. We have we know file name filter is an interface which needs to be we need to define a particular class with this file name and then provide definition for this particular method, except method. Okay, so so we are listing that by passing the here. Okay, this is the filter we have defined, and we are passing filter here. while displaying the list of files that are available in a particular directory. Okay, so here we have except method. Okay, but we are not, when trying to test it, we are not calling except method here. We are just calling list method by passing filter. And how is that except method is called? That is what was her question. So the list itself will call, this list method itself will call the except. We need not have to call this except method. Okay, so if you want to see the definition or how that list is defined, right, that itself you can see here. This is what your list method, how the list itself is. Okay, the logic behind your list method itself. Okay, here we are calling that except method. Internally, list method is calling your except method while trying to list out the files in a particular directory by passing filter. Okay, whatever the filter that you pass in this, okay, based on that one, except method will be called. For example, if you try to put, right, so if you try to put debug statements or your print line statements, you can see this, see here. Before calling the list method, so after calling this list method, the list itself is calling except method. With the number of times it is called is like for each file that is there in a particular method, it checks whether the filter condition matches or not. Okay, based on that one, it returns the respective file object. Okay, so I have replied to you, Shram, to clarify your doubts. Okay. Okay, so let me know if you have any questions. Otherwise, we can wind up this class. Okay, we'll meet at 8 o'clock or 8:30. I'll let you know if at all any changes are there. I'll let you know the timings. Otherwise, we'll meet at 8 o'clock. And we'll discuss a few more topics. Okay. I think I might need one more class for util. Let's see if we can cover it in our next session. Util package. Afterwards, we'll go to threads. Okay. Probably 1 or 2 classes should be sufficient to cover. Minimum 2 classes should be sufficient to cover core Java. Afterwards, we'll jump into advanced Java. Okay. Okay. How to get file class? So file class, you will get it. It is like I have this version of Eclipse, right? That is our Mars, I guess. I think it is Mars only, I think, and I am not sure. I don't remember whether I have installed a decompiler for this particular Eclipse. I don't remember. So that is what decompilers help you kind of like when you click on this particular method, right, which is your library method, the decompiler decompiles the file class. Okay, so you can see here, this is not a Java, but the decompiler has decompiled the file and it is showing the definition for that. Okay, if you have Eclipse and if you don't have decompiler installed in that or decompiler plugin installed for your Eclipse, you can download it. Okay, from market, Eclipse market. To search for decompiler, you will get it. You can install it. Okay, for example, okay, both byte, maybe there may be bytecode visualizer. So many things are there. Whichever you want, you can. Yeah, I think that clips is what I have in my Eclipse. I don't remember now whether I have installed it or not. But if I have installed, I would have installed this particular plugin. Okay, you can install it, and if you want to go through the methods, right, whichever you have doubts, you can kind of like do this. Okay, yeah, okay. Let us wind up this call. We'll meet in the evening. Okay. Thanks everyone for attending this session. Have a great afternoon. So we'll meet in the evening. Thank you again. Yeah. Bye bye.